Hi, this video is about arc length, and that might be something that you think you've done before, but actually it's not, because arc length is different from arc measure. They both sound a lot alike, but let me explain the difference. Looking at my picture here, you can see that I have a circle, and I have a central angle in my circle, and I made the arc that goes with it red, just to make it maybe stand out a little bit. And of course we know that a central angle exactly equals the arc that it creates. And so this arc would be 119 degrees. That's the measure of the arc. And if I change the central angle, the arc would change. We know that. And that's how we get the arc measure. But arc measure doesn't tell the whole story, because right now this red arc, take a look at it, is 125 degrees. But as I change the size of the circle, that arc continues to be 125 degrees, because that measure is telling me what portion of the circle has been cut out. And if the circle's tiny, it's the same portion, the same percentage, if you will, than if the circle is large. And so arc measure alone doesn't tell me everything I need to know. I know what part or what portion of the circle has been cut out, but I don't know how big the original circle was, so I don't know if it's a big arc or a little arc or anywhere in between. That's where arc length comes into play. Arc length is what you would get if you took a ruler that you could bend and you measured along this red arc from one point to the other. Centimeters, inches, whatever unit you chose to use. And so that would make a difference, because this arc would have a different length than, say, that arc. And so arc length kind of tells the rest of the story. Like, okay, yeah, it's 125 degrees, but here's actually how long this thing is. And arc length is then related to circumference. So let's talk about that. If I talk about, old leftover stuff. If I talk about circumference, first let's review. The formula most people use for circumference is 2 times pi times the radius equals the circumference. You can also use pi times diameter, but more often than not, we have the radius in our problem, so we tend to stick with this one. Arc length is part of that circumference. Excuse me. So what I'm going to do is set up a little proportion, because we're talking about parts and wholes, and that's what we do a lot of times. And so I'm going to say that arc length, that's the part, just the red part in my picture, over the whole circumference equals, I'm going to do a part over whole on this side as well, but now I'm focused on degrees. And so I'm going to say arc measure over the whole circle is always going to be 360. And again, just a reminder that arc measure is the degree measure. It's the same as the central angle. And so part of the length over the entire length, the circumference, equals part of the degrees over the whole degrees. And I can plug in everything that I know, and I can solve for what I don't know. Now, for this part down here, we could either leave it as C if they wanted to know the circumference, or they gave us the circumference, or we could substitute here and put in a 2 pi r if the problem has to do with radius, or we could put in a pi d if the problem has to do with diameter. So let's take a look at my problem. Let me grab this and go ahead and label its length. For my problem, if I were looking for the arc length here, let's plug in what I know. I don't know the arc length, so I'm going to call that x. That's what I'm trying to find. The circumference, well, this is the radius, so I'm going to use this formula. 2 times pi times my 4.5 equals my arc measured degrees over 360, so 125 over 360. Once we do that, we have a proportion that looks pretty much like they always look. We know everything. They're all numbers except for this one thing that they're asking for. Keep in mind that pi is a number, not a variable. And I can absolutely cross multiply and solve. So 360 times the x equals, I'm going to go ahead and grab my calculator, and I'm going to do 125 times 2 times 4.5, and I got 1125. Now you might notice that I did not multiply by pi. I didn't want a big ugly decimal, at least not yet. So pi is still just sitting there, giving me flexibility in my answer. To get x by itself, I do need to divide both sides by 360. And so x is right there. Now the problem would probably tell me what I needed to do with my answer. Since I don't have instructions on this made-up problem, I'm going to do it this way. I calculated the 1125 divided by 360. I went ahead and did that number, and I've got 3.125. And then pi is just going to sit right there. That's an exact answer. I did not round. I like that answer. I don't have to deal with anything. But if the problem said round to the nearest hundredth or something like that, then I would go ahead and multiply by pi and round as the problem stated. I like exact answers unless told otherwise. So that's how you find arc length, which is part of the circumference, by using a proportion.